Hello there. In today's video, we will be covering part 1 of a series of videos focused on the programming paradigm called object-oriented programming. We will learn this paradigm using the language Python. Now, the syntax of Python may not carry over to other languages, but the concept of object-oriented programming will. So, if you have a background in another language that supports object-oriented programming, such as C++, this video will still be helpful. Let's begin by creating a file called intro0.py. What will we be covering in this series of videos? We will be covering object-oriented programming as a grand idea. We will cover classes and objects. We will cover something called encapsulation, an idea called inheritance, an idea called polymorphism, and an idea called abstraction. These concepts will make it easier to maintain and modify existing code when it comes to creating classes and objects. So we can keep this here if we want, but we can also remove it. Let us go ahead and start the actual video. Before we begin discussing object-oriented programming, it is important for us to review how we have been programming so far. You have been programming so far using a programming style called structured programming. So what is structured programming? Structured programming represents the system in terms of data and the processes that act upon that data as separate components. Let us write a little script to emphasize this fact. Let's say I have some variable x and some variable y assigned to some values. And let's say that the above represents data. I'll then create some function. Let's call it sum, and it takes in two parameters, a and b. And all it does is returns a plus b, the sum of a plus b. The function represents the process. How do we get our function to interact with our data? There are many ways. We could just say sum and pass in the values x and y. We don't get output, we should wrap it into a print statement. And this way, we combine the data and the process that acts upon that data. And we can save and run this file. And we get the output of 7. 5 plus 2 being 7. Now, we can create amazing programs using structured programming. Most likely, you already have created amazing programs. Let me give you a little example. Let me think. Let's create some function. It will take in some parameter called file name. Let me actually zoom in a little. That's good. I'll create some container called lyrics count, and it'll be a dictionary. I will open the file name or the file in read mode so I can read the data. I will pass in an alias called as file just so it's easier for me to work with. I will then say words. No mistake, I should actually iterate over the line in file, and I say words is equal to line.split. I will split it based on a space character. I'll then say for word in words, word is equal to word.strip dot lower, just so that I normalize the output. Normalize. I strip whatever I don't need and I make it into lowercase. And then simply I can do the following. If word in lyrics count, all I want to do is increment that value of the word by 1. Else, the first time we see that word, I will initialize it to the value 1. So if we just notice what this does, we create an empty dictionary, we open a file, we iterate over the lines in that file, we split it using a space character, giving us the individual words. We then do some pre-processing, just so that all our words are essentially the same format. We then use this if-else block to determine if the word is in our dictionary. If the word is in the dictionary, all we do is increment the value by 1. If not, we will set its value to 1 the first time we notice the word. Now, outside that, with open statement, we can do something like this. Top 3 is equal to sorted, and we'll pass in lyrics count dot items. We'll sort it based on that. We'll pass in some function. We'll create a one-line function called a lambda function, which takes in one parameter, and we access the value. So we say x1 and reverse equal to true. And I want the top 3. And then I can say return top 3 returns a tuple of the top 3 words and their associated counts. Top 3 unique words. That is what this function should do. Now, unfortunately, I have nothing in my folder, so I'm not going to run it, but if you copy this code, that's what it should do. I don't think there's any errors. Let me just go over everything. All right, for line in file, words is equal to line.split for word in words. It looks good. But as we see, we can create good programs using just structured programming. You can save this somewhere, you can just comment it out. I am going to remove it. I no longer need it. Let us now finally get to the meat and potatoes of this first video. And that is, what is object-oriented programming? What is this? So, remember, I said structured programming treats processes and data as separate components. Object-oriented programming combines data and the processes that act upon that data into a single entity called an object. Now, you may be asking, well, how do I combine them? How do I create objects? This is where we come across our next definition, the creation of user-defined types. Objects, we can call them classes. So a class is a blueprint for creating objects. Objects are instances of a class which can have attributes, which are also called properties, which are also called members. and behaviors, which are called methods. But we will get more into that when we start creating our class. So all we're going to do is use the following syntax. It's class followed by the name of your class, and we pass in something called object, colon, and we can write stuff here. For now, all we're going to do is write pass. So following that syntax, we create class, and let us model a object of type exercise. We pass in object, colon, and pass. Save everything. Congratulations. You have created a class from which you can create objects. You have basically, at this point, you've mastered object-oriented programming. You are done. You know everything. So, how do we create an object using our class definition right here? All we're going to do is pass some variable name. I'll say exercise1 is equal to, we call our class, we pass in the parentheses. We have just created an object of type exercise. We can also say we now have one instance of the exercise class. Let's list some facts about an exercise. If we want to think about a squat, a deadlift, a bench press, what are some things that represent them? Well, they must have a name, they must have a number of sets, they must have a number of reps. And we can achieve this by doing the following. We call our instance, in this case exercise 1, we use something called the dot operator, which is just a dot, and we pass in some attribute, in this case name, and we say it equal to some name. In this case I'm going to say it squat. I can do it again, exercise 1, and I can pass in sets, and I can say 2 sets. Exercise 1 dot reps, and I can say 4 reps. I can go print, I can go exercise 1, I can refer to that attribute which I created called name. I can also do exercise 1 and I can refer to sets. I will also just print out an X, exercise 1 dot reps. I will save everything and I will run my file. And I get squat 2 by 4. Squat 2 sets by 4 reps. Let's do it one more time. I want you to create an object of type exercise with the name deadlift, 2 sets, 6 reps. I'll give you a few seconds. All right. We've probably done something like the following. You would say, okay, exercise 2 is equal to exercise. You can add a little comment. We just created another instance of type exercise. This line here, when we create an object, is called instantiation. The process of creating an object is called instantiation. We can also say object is equal to instance, which is equal to occurrence. So we right now have exercise 1 and exercise 2. That means we have 2 objects of type exercise. We can also say we have two instances of type exercise. We can also say we have 2 occurrences of type exercise. And then we probably listed off the attributes. So exercise 2 dot name is equal to the name deadlift. You gave it some sets. In this case, I said 2 sets, I believe. Yes, 2 sets. Exercise 2 dot reps, and I said 6 reps. Why am I doing that? Right. And we can just copy this. We can come down here. We can paste it in. And we just change exercise 1 to exercise 2. Let us save our file and we can run it again. Notice we get squat 2 by 4. We get deadlift 2 by 6. Great success. Let's go ahead and create just one more instance of type exercise called exercise 3, and we do the following. I'll go a little faster. Let's go 4 sets, and let's go 8 reps. Let's save everything. Let's run our file. Okay, great. We get bench press 4 by 8, deadlift 2 by 6, squat 2 by 4. So we so far have 3 instances of type exercise. Let's analyze the code we have written so far. Just go ahead and say analyze what we so far. We had some behavior that we wanted to implement. In this case, we wanted to create an exercise object. And the reason why we want to do this is, well, there are no exercise objects in Python. There's strings, there's integers, there's floats, there's booleans. But there's no exercise object, so how would we model an exercise? We could always create something like a dictionary, where the key can be an exercise name, the value can be a list containing the name, sets, and reps. But you notice how I just said we would have a dictionary with a name within which will be a list. It will grow very fast. It'll become very big. It'll become a little annoying to work with. So we decided we will create our own object using object-oriented programming. We created a class called exercise with which we can create objects of type exercise. Now, you may have a few questions. The first being, why do I pass this thing called object? So, in Python, there are many types, strings, integers, etc. They all have some behavior unique to them, but they also have behavior that's shared amongst them. That shared behavior comes from this thing called object, and that is why we pass it into our exercise class within the parentheses. But because all types in Python share that behavior, we actually do not need to pass it. And the reason we don't need to pass it is Python inherently knows that when you create your own user-defined types using a class statement like I have here, it basically knows that it's passing an object. So you do not need to pass it in. It is basically redundant. So if we remove object and we run everything, it's still the same output. It still works. I believe in Python 2, it was required for you to pass object, but no more. The next thing we notice is that when we create an object of type exercise, we have one line called our instantiation line, and then we have 3 more lines to get our attributes, name, sets, and reps. We also have another line to print out that name, sets, and reps. A total of 1, 2, 3, 4, 5 lines for one object. And we also do it 2 more times. So we had 3 objects, and each took 5 lines to achieve what we wanted to achieve. 3 objects, 5 lines, for a total of 15 lines. And that may not sound like a lot, but what if I wanted you to create 10 objects of type exercise? Well, 10 objects times 5 lines is equal to 50 lines of code just to create the object, pass in name, sets, reps, and to print it. What if we had, say, what if I wanted you to create, say, 2 objects times 5 lines? I believe that should be 160 lines of code, where a lot of that code is essentially just the same thing, but slightly different. If we notice, we have exercise 1, we create it, we have exercise 1.name, we set the value, exercise 1.sets, we set the value. But we are repeating that same pattern over and over again. Now, I will leave this here as a comment so we remember what we're about to do. There must be some easier way for us to achieve this functionality in Python. Let me show you something. Within our class definition, I want you to do the following. Define. We are about to create a function, but not just any function. A function called a double under method, also called a dunder method, also called a data method. So define 2 underscores init. And we notice that our initialization function got added some parameter self. Well, what is that self? Let's go ahead and print self. For now, we can get rid of pass, we can save our file, and let's run it. What is this? Let me actually, for now, just get rid of these print statements. So I'll save everything. I'll clear this output. I'll run our file. So for some reason, we are getting this main object at some location, main object some location. But we aren't calling print anywhere. Notice that I commented out our print statements. So why are we getting output to the terminal? Do you see this function right here called define double underscore init? This function will run every time we create an object of type exercise. Why will it run every time we create an object of type exercise? Well, that is how the function was built. So when we create an object using this line here, exercise 1, and when we create an object using this line, exercise 2, and when we create an object using this line, exercise 3, this function runs. And all it prints out is something called self. Well, what is self? Self refers to the current calling object. In this case, it will be exercise 1 the first time we create an exercise. So this is equivalent to print exercise 1. In fact, I will prove it to you. Let me just leave that there, and below exercise 1, I will print exercise 1. I will save our file, and I will run it. Now notice, we can ignore these two, but focus on the first one. Main exercise object at some location. That same print statement is repeated here. That is how we know that the self object is being essentially exchanged with the current exercise object. If you're wondering what this output is, all it means is we have some exercise object at some location in memory. 0x means that what comes after is hexadecimal. So all it says is we have some exercise object residing somewhere in memory. Cool. We can get rid of that. We now know that when we create an object, the moment we do the process of instantiation, which is creating an object, we can run some function. Well, because we can do that, it means we can go ahead and slightly change this function and alter it to make it advantageous to us. Let us pass in more parameters to our function. such as name, sets, reps. And all I'm going to do is I'm going to say self. Remember, self essentially refers to the current exercise object. That's what you can think of self as. So self dot name is equal to name. Self dot sets is equal to sets. Self dot reps is equal to reps. So what this means is basically think of self for now as being exercise 1. And we pass in 3 more parameters, name, sets, and reps. The moment we create our exercise 1, we want to give it a name. So what we say is self.name is equal to name, which is the name we pass in parentheses, which is the same thing we do with sets and reps. And because we did that, we no longer need this. We can remove that. And when we create our object, do we pass in the value self? No. Python inherently knows that the current object will be passed as the parameter self. So there's no need for us to pass in exercise 1 and say it's equal to self. There's no need for us to do that. All we have to do is pass in all parameters that are not self. In that case, we need to pass in a name, a set, and a reps. We pass in a string for squat. We pass in an integer for sets, and we pass in an integer for reps. And now when we print exercise 1, where is that? Oh, okay. So I'm just going to comment off this out for now. Save everything. Let me go back to my terminal. And let me run my file. And notice, we get squat 2 sets times 4 reps. Because all of that functionality that we were doing in 3 more lines is being handled by this initialization function. And we do this because we know this function will run every time we create an object. Let us do it with exercise 2. If all I do is uncomment this out, I remove in this name, sets and reps. I can go here and I can pass in the values. Can I do deadlift? Can I pass in 2 sets? Can I pass in 6 reps? Then all I'm going to do is print exercise 2 dot name, exercise 2 dot rep, sets, and exercise 2 dot reps. That's all I'm going to do. And I'll run my file again, and again, success. I get deadlift 2 by 6. And I didn't have to go again and create those attributes myself. They are all being handled by this init function. So, a function that appears within a class definition is called a method. If that method starts with 2 underscores, it is called a double underscore method, also called a Dunder method, also called a data member. Now, before we end this video, I want you to change this from being 5 lines to being 2 lines. 1 line to create our object and 1 line to print our object. How would you do it? Alright, so you realize that there's no need for you to pass in exercise 3 as self. You know that all you have to do is pass in all other parameters. In that case, bench press as the name, some number of sets, let's say 2 sets, some number of reps, and you then all you do was print exercise 3 dot name because you know the name attribute exists, exercise 3 dot sets because you know that also exists, some x, and exercise 3 dot reps. Save your file, and then you ran your file. And you got out the output bench press, deadlift, and squat. Great. We have done quite a bit in this video. But let's do one last thing. Let me introduce you to another double underscore method, something that will make printing a little easier. Let us go within our class definition, say define double underscore str double underscore. Str stands for string. We must pass self whenever we create a double underscore method, a colon, and let's start writing our function. Now remember, self will always get exchanged with the current calling object of type exercise. And because that happens, we can say print self.name, self.sets. We can also print out an x, and we can say self.reps. The string function, the double underscore function will run whenever we call print exercise object. So if what I said here is true, the string function will run whenever we call print exercise object. It means instead of doing print exercise1.name, exercise1.set, exercise1.reps, we can just say print exercise1. But it also means we can just say print exercise2. And it also means we can just say print exercise3. If that's true, let's figure it out. Yes, my mistake. It should be return, not print. Return self.name. Clear. Turn non-string type. Oh, okay. So I am actually making a mistake because these are integers. All I'm going to do is wrap them in the string to change the type. A silly mistake that can be easily corrected. Let me also just add. Okay, I think the comma should be fine. Clear. And string return non-string type tuple. Oh, yeah, okay, I see. So I do have to get rid of the comma. I'll say plus some empty space plus some empty space and plus some empty space. And that should be good. I will clear everything. Str string. Is the wrapper not called string? Am I getting confused with my Python? Because I need to say plus here as well. That's the issue. Alright, plus here as well. I'll make this comment a little neater. I'll put it up here. The string method will run whenever we call print exercise object. Go to run. And there we go. Success, finally. We get bench press 2x8. Squat 2x4, deadlift 2x6, bench press 2x8. A little too much of space here. I need to sneeze. Bless me. But yep, as we see, all I'm doing is printing the exercise object 1. And when I say print exercise object 1, Python knows to look within my class definition for a double underscore string method. It finds it, and what it says, okay, where you see self, exchange it with the current exercise object, in this case exercise 1. Wherever you see self, exchange with exercise 1. So exercise 1, exercise 1. Now this function should be similar to what we've been writing so far. So why do we have to wrap our output in the string function? Well, Notice that this function is called double underscore str, which means double underscore string. It must return a string, but sets and reps are integers. Therefore, we wrap it in strings to convert it to a string. And the reason we couldn't use commas is because we must return a string. If we use commas, we are now returning a tuple. So all we have to do is correct this statement a little, and it will return a string with the exercise name, the exercise sets, and the exercise reps. This may be a little too much of space. We run it one last time, and there we go. Everything's right in the world. And that is all for this video. I hope you learned something.